Hey folks, it's David with Streaming Relativity, home of the AstroDNA Observatory, and today we're going to talk about calibration library management, and specifically we'll deal with manual pre-processing of your bias, your darks, and your flat frames. Now, I did a video, in fact my very first video on the channel, on calibration libraries and what each of these files what these files are used for. I will leave a link to that video. Warning, it was the very first video I did on the channel, so the sound quality is horrific. I also did a video on the essentials of stacking with Siril, and if you haven't seen that video, you should add it to your playlist. So in this video, we are going to refresh ourselves on a calibration library. We'll open up Siril, get oriented to the UX for the workflow that we're going to follow, and then we'll systematically pre-process our bias, our darks, and our flat frames. And obviously we'll put them to a test by stacking an image, and then we're just going to fade out into the sunset. But we're not going anywhere until you subscribe. If you are into astronomy and all things astrophotography, you're going to love this channel. In the last, call it 9 months, I think I've published over 60 videos. I think there's a wonderful community that has developed here, and you'll find a lot of good content. So go ahead and subscribe. I really appreciate the support. And with that, let's hop into calibration libraries. Okay, we all want really awesome astrophotographs, and in order to get really awesome astrophotographs, we need good clean stacks. To get good clean stacks of our image data, we need to use calibration frames, and there are 3 types of calibration frames that we're concerned with. First is the bias frame. The bias frame simply represents inherent fixed noise that exists on every sensor and usually makes itself apparent during a read process. Dark frames. As we take exposures in astrophotography, those exposures tend to be very, very long, and the longer the exposure, the more the chance of dark currents developing on that CMOS sensor, and those become sources of noise. We want to remove any of the dark current with dark frames. And then finally there are flat frames, and everybody knows that dust is present and gets on our sensors, gets on our filters, smudges. All sorts of things can get in the way of our optical train, and flat frames are used to kind of identify those artifacts, the uneven illumination, and then correct for that in your light frames. So those are the 3 types of calibration frames that we need to create. So I was browsing my raw data to try and find a target that I could use for this tutorial, and I came across M101, which I shot on 10/5/2024, and it looks like I've got about 85 subs, and those subs were shot at a gain of 140, offset of 25, and an exposure time of 60 seconds with the ASI 2400 MC Pro camera. Okay, so that tells me that I need a bias and dark frame at a gain 140, offset of 25, a temperature of -10. The bias I'll shoot at 1,000th of a second, and the dark will be at 60 seconds to match the light frames. It also tells me that I got to shoot flats, and that is through the rig, and those flats will be again gain 140, offset 25, temperature of 10, and we'll shoot that for, in this case, just the built-in IR UV cut filter that comes with the camera. So I shot my calibration data on the 17th of September, and I have moved it into a workspace that I'm calling Calibration Lib Builder, and you'll notice that there are subfolders that I've created within that master folder, and the naming convention I'm using matches the naming convention that Siril's documentation publishes with regards to their scripts. You can name this stuff anything that you'd like, and you can alter your organization as you see fit. But for now, I've loaded the bias frames into the biases folder. I've loaded the dark frames into the darks folder, and I've loaded the flats frames into the flats folder. And then I went ahead and created a masters subfolder where we'll store the stacked master calibration frames, and I've created a process subfolder. Again, this is not necessarily required, but it does match up with the hierarchy and naming convention that Siril publishes in their documentation for the use of their scripts. Okay, step one, we'll open up Siril and set our working directory, and we're going to set that to the process folder of our Calibration Lib Builder workspace. All of the files that are created by Siril during this workflow will now reside in the process subfolder. So we're going to work the bias frames first, and the first thing we'll do is we'll load the bias subs and convert them into a sequence that we can then process. And in our case, all that we're going to do is stack. And when we stack, we're going to do no normalization, average stacking with rejection, and we're going to give it a name. And in this case, I'm going to save this in the masters folder. We should note that bias and dark frames are a function of the camera itself and only the camera. They do not involve any of the optics of your rig, and for that reason I use a naming convention, which is the name of the camera, the gain, the offset, and temperature settings, and then master. Now, the nice part about this naming convention is I can now easily identify my bias master frames for this camera regardless of what rig I'm using it with. So here we are stacking. I think it takes a whopping 12.9 seconds to complete. Great, and now we can see the master in the masters folder, and we can go ahead and repeat this process for our dark frames. So we go back to the conversion tab. Let's delete all of the files in that list, and let's create a new sequence, and we'll call it dark. And of course we'll add all of our dark subs. These were taken at 60 seconds, and we've got them in the folder. Let's add them. And then we're going to convert this into the dark sequence. Okay, voila, we have our dark sequence ready for stacking. No pre-processing on darks. Again, average stacking, no normalization, and just give it a name that you will be able to use in the future. Again, we're going to save out to the masters folder. In my case, it's the name of the camera. It's going to be the gain, the offset, and temperature, and then be master dark underscore 60 seconds. And then of course we do the stacking. And in this case I think it took about 11 seconds or so to stack these darks. Let's just confirm by checking the masters folder in our working directory, and sure enough we've got it. Okay, so far so good. We have both our bias and dark frames stacked into the masters folder. It's time to do the same thing for the flats. So we'll add our flat files to the conversion tab, and we'll convert them into a flat sequence. Unlike your darks and your biases, we actually have to do a calibration step with our flats, and what we're going to do is actually subtract the bias signal from the flats. We're also going to set equalize CFA and auto normalization. This is just going to make sure the brightness levels across all of your flats are normalized with each other, as well as the CFA channels. And this is interesting because this is how it's documented in the manual pre-processing step, but if we look at their scripts, they actually don't execute these options. So you may experiment with both methods here to see what flats work best for you. Okay, we hit calibrate, and about 30 seconds later or so we'll have our calibrated frames. Our next step is to stack. This will be average stacking with rejection, but our normalization method will be multiplicative. Leave pixel rejection at Winsorized Sigma clipping. Do not check off output normalization or RGB equalization. Just give your master a good name. This is a flat, so I name my flats with the telescope, the camera, the gain, the offset, the temperature, master, flat, and then underscore the filter. In this case, this is no filter. There is a built-in IR UV cut filter for the ASI 2400 MC Pro. So let's go ahead and stack. Should take about, I don't know, a minute or so. And we can confirm the stack was created by checking our masters folder. Alright, we have all 3 files needed in order to do calibration of light frames. So why don't we do that? Okay, so the first thing that we're going to do is we're going to create a folder called Lights, and that will be in the Calibration Lib Builder folder. And we're going to move over all of our raw frames that we captured on M101 back on the 5th of October, and we'll just copy them over into the process, into the Lights subfolder. Okay, terrific. We've got our light frames loaded in our workspace, and what we're going to do is convert them. And we're going to call this sequence light. Okay, and we'll convert. Done, and we'll throw an auto stretch on just to take a look at what we're dealing with. And what we're going to now do is calibrate these frames. So obviously this is M101, this is a 60-second exposure. You can barely make out some of the spiral arms in here, but they are there, and I can see that I have some artifacts, dust motes, and there's a little bit of, there's obviously some vignetting here. Okay, we have our light sequence selected. Let's go ahead and go to calibration. And a couple of things. We're going to use the master doc that we created, and we'll grab that from our masters folder. And we're going to use the master flat. There's no need to use the bias because the bias is incorporated in the dark frame, and so all we need is the flat and the dark at this point. We are going to equalize CFA. We're going to definitely auto evaluate normalization values, and cosmetic correction will stay. CFA data is checked off, but this time we are going to debayer as a part of calibration. Okay, so let's start the calibration. Okay, so when it's calibrated and debayered, we see this green hue. Let's just unchain the color channels, and already you can tell that even calibration alone has done wonders for these subs. The galaxy is far clearer at this point. So let's go ahead and let's do a registration. We'll do a global star alignment, and this will make sure that each of our calibrated frames is properly aligned using a reference frame. The reference frame is picked automatically by Siril. You can always set your own reference frame if you prefer, but this is a simple demonstration here, so we'll just let Siril do its thing. Okay, so we have our registered files at this point, and we're going to jump right into stacking. Normally I would go through the plot and kind of selectively remove frames that were terribly out of focus or what have you. For this demonstration, I'm not going to do that. We're going to do average stacking with rejection. We're going to do additive with scaling. And pixel rejection, we'll leave it the Winsorized Sigma clipping, 3.3. These are all default values. The difference here is that we are going to normalize the output, and we'll do some RGB equalization. And I'm going to drop this into our masters. And we'll call it M101 stack. Okay. And why don't we go ahead and start stacking. Okay, very good. So here we have our stack, and it's in pretty good shape actually. There's some issues of vignetting still, and that's to be expected, frankly, with this rig setup I have. I'm using the C11 XLT without a focal reducer. Either way, it has an image circle of about 26-27 millimeters. This is a full frame sensor, so coverage on the edges is just not rational to expect. But when I crop this down, it's actually going to look really nice. All right, so one other thing before we move on and summarize this, I want to demonstrate how the same exact workflow that I've described right now, we can actually run the scripts. So let's go to the workspace for a second and take a look at the masters folder. Let's make sure we have our M101 stack. We do. What I'm going to do is I'm going to empty out the process folder entirely. And we're going to leave everything else alone. So at this point, we have an empty process folder. We have our light frames, we have our flats, our darks, our biases, and we have our masters named using our convention. If we go ahead now and set our workspace to the actual calibration lib folder, open, and let's go ahead and run the script itself. We're going to go to scripts, and we're going to run the OSC pre-processing script. The reason why I'm doing this is that, if you recall, in the script they do not equalize CFA and they do not normalize when they stacked their flat. I want to see what the difference is between the stack we just created and the stack that's created by the pre-processing program script itself. So we'll select that, and it's going to go ahead and do it's going to rebuild the bias, the dark, the flat, and it will stack the lights and do everything that we just did. So let's follow along and see how it does. Okay, so the script has completed. It took about 14 minutes to run. Let's take a look at, let's open up the file that it created, and let's see whether or not we have any difference. Well, looking at it, it doesn't look entirely different. Maybe it's, I believe it's flipped, but maybe a little less, a little more gradient, I think, in this than the image that we created manually. So I do think that the script does not, by not executing CFA equalization and normalization on the flats, I actually think the result is not as good. That's just my opinion, but either way, you can experiment on your own and decide. Notice how it did create its own dark, its own flat, its own bias, and this, remember, was our result. Let's open up this and take a quick look and see if there's any appreciable. I think that this is a better stack. So, okay, with that, this goes into PixInsight, and with a little bit of playing around, we get to this beautiful image. Okay, folks, let's call that a wrap on the video. I hope you learned something about calibration library management. I hope you picked up some tricks or techniques relative to manual pre-processing. And obviously, I hope that you're able to put all of this to good work and produce some amazing astrophotographs. And if you liked the video, hit like. If you want to share a comment, please do. And of course, if you're not subscribed, go ahead and subscribe. Your support is greatly appreciated. And with that, I will see everybody on the next video.